Okay, this part, what we're going to do is we're going to finish up coterminal angles and also arc length and sectors. So this is going to be arc length and sectors. We're going to do that in just a second. Area of sectors. That's what's coming up really quickly. But first, we're drawing angles in standard position. So we went through with the degrees. Now I'm going to give you some in radians so you can practice drawing those as well. So what if we have to draw pi over 6? We already did this one, but this will be easy for us. Pi over 6 is what we need to draw. Okay. And then the second one I'm going to give us is 2 pi over 3. Okay. And then the next one I'm going to give us is 4.3. So this is an example of an angle that does not have a pi symbol in it, but it's in radians. And we know it's in radians because we don't see the degree symbol. And then this last one's going to be 5.75. This is the same thing. It's another angle in radians. And we know it's in radians. Oh my goodness. Because no degree symbol. So let's go through this. Pi over 6. This is 0 radians, and this is pi over 2. So pi over 6 is smaller than that. And we remember it converts to 30 degrees. This is pi over 6. This is how we will represent this. Pi over 6. All right. 2 pi over 3. This converts to 120 degrees. So sometimes I have to think in degrees in order to put things on here. So 120 would be between 90 and 180. So 2 pi over 3 is going to be about right there. So this is the angle in standard position. Theta is 2 pi over 3. What about 4.3? Okay, let me think about this. This doesn't have a pi in it, but I know that this is 0, this is pi over 2, this is pi, and pi is about 3.14. So it's going to be a little bit bigger than 3.14. It's maybe right here. So we'll say, oh, I shouldn't have drawn those arrows on there. Here's my initial side, and here's my terminal side. This is what theta is going to equal to, 4.3. What about 5.75? Well, this is 0. All the way around is 2 pi. 2 pi is about 6.28 if you look at that chart we did earlier. So it's going to be a little less than that. So maybe this. From here all the way around to here is theta is 5.75. Okay. Now, I'm going to go through this as fairly quickly, but you'll see what's happening. You can get coterminal angles all the time. If it's in degrees, just add 360. Add another 360. You can keep getting coterminal angles or subtract 360, 1 revolution. So, right here, 68 degrees. The next thing we're going to do is we are going to sketch and label 1 positive angle and 1 negative angle that's coterminal with the given angle that we've just drawn. So these are the angles. In blue is the standard position. Now I'm going to draw one in green, which is going to be positive. So if to get a positive coterminal angle, I'm going to go cycle 360 and then add a 68. And so what that ends up being is 360 plus 68 in green is going to give me 428. 428 degrees is a coterminal angle. Let's go through and do all the positive ones. Let's see. I will just cycle all the way around to 360 and then I'll go another 170. So if I do that, that's going to be 530 degrees. Let's do a coterminal one here. Go 360 and then all the way around. That was a lot of cycling, but this one gives us 700 degrees is coterminal right there. Let's go cycle 360 and then this much around, and that gives us 255. So those are some positive coterminal angles. If we needed another one, we would just cycle around another 360, add another 360 to that. Let's go, let's find a negative one. So to go negative, we go in the clockwise direction. And so an angle that will be coterminal with 68 degrees will be, what if we just start with this initial side and we go all the way to here to this terminal side that far, how we got that would be 68 degrees minus 360, and so that gives us negative 292 degrees. All right, let's find a coterminal angle. Here's my initial side, and then we're going to go this way to there. Red would be 170 minus 360, so that coterminal angle is going to be negative 190 degrees. If we start here with this initial side, right, and then we want to end up here, to find a negative one, we could go that direction, and that's going to be 340 minus 360, or negative 20 degrees. Let's find a coterminal angle. This is my initial side. This is my terminal side from here to here. I could do that. So 255 minus 360 would give me negative 105. Okay, I see a big mistake here. I got 255 again. That's not right. This is 255 plus 360. That's what that should be. And so that gives us 615. Is that right? Yeah, 615 degrees is what that is. It's 255 plus 360. Okay, we can do the same thing with radians, only instead of adding and subtracting 360, we're adding and subtracting 2 pi. So, goes like this. Let's just first draw a coterminal angle here. Cycle all the way around with just 2 pi, and then add another pi over 6. And so that's going to be 2 pi plus pi over 6. So times 6 will be 12 pi over 6. This is, the green is 13 pi over 6. Here, let's draw a coterminal angle here, all the way around 2 pi plus another 2 pi over 3. So 2 pi plus 2 pi over 3. Let's see, times 3 will give me 6 pi over 3. So 8 pi over 3 is a positive coterminal angle there. Cycle all the way around, and then this far. So that's 2 pi plus, 4.3. So I'm not going to do fractions here. I'm just going to use my calculator. 4 pi plus pi over 3 gives me about 10.6. This is going to give me 10.6. 5.75 plus another 2 pi. That's a lot of angles. That coterminal angle gives me, it is about 12.0 when I add 2 pi to that. So those are the positive coterminal angles. Again, we can do it negative. We're going to take, we're going to go clockwise. We start here with this initial sign and we go this way. So we took pi over 6 minus 2 pi, and that gives us negative 11 pi over 6. Start here, go to here, opposite direction. We get a negative 4 pi over 3. If we start here and we go backwards to here, we take 4.3 minus 2 pi, and that gives us negative 1.98 about. If we start here and we go here, we take 5.75 minus 2 pi, we get negative 0.53. So those are coterminal angles. Now, we are ready to tackle the word problems on this. We're finally able to see arc length and area of a sector. So let's look at these guys now that we have finished this stuff about coterminal angles. Arc length is how much of the circumference of the circle that you're finding, okay? That's what arc length is. And it's, the units on that are in inches, feet, centimeters. It is actually a length. And then the area of a sector is how much area is enclosed by that arc. So I'll draw that, but the units on area are the same as they are if you were doing any kind of area. They're in square feet, square centimeters, square meters, the same as they would always be. So here are two very great formulas that we get to use, but here's the catch, is that the angle always has to be in radians if you're going to use these. The angle has to be in radians, not degrees. So if they give you an angle in degrees, you can still use this. You just have to convert to radians, and we know how to do that. So if we have some circle here, and here is the center of the circle, and we have some angle here, and this is the central angle that subtends this circle. This angle is theta, but if it's in radians, we can use these formulas. Okay, so what does this mean? The formulas, S is the variable that we give to the arc length. What is the arc length? It is this much of the circle. That is S, okay? And S is equal to R times theta. And so, that is great, okay? Then we can talk about the area of the sector. So if that is, the area of the sector is this much, like if you think of pizza or pie, how much you get to eat, how big a slice it is. So this is the area of the sector. And so there's a formula that we can use for this, which is that the area is equal to 1/2 r squared theta. And the deal is theta has to be in radians. So we remember how to convert if we need that. So the first example that we have is, it says in a circle of radius 5 inches, the radius is 5 inches. Find the length of the arc subtended by a central angle of A, theta is 0.228, and B, 37 degrees. So the job here, in a circle of radius 5 inches, find the length of the arc subtended by the central angle. Find the length of the arc. Find the arc length. Find S. Find S. S is equal to what? Okay, so in part A, this angle that they gave us is in radians, and I know that because I don't see a degree mark. That means I'm good to go. I can use this formula. So S is going to equal to the radius, 5 inches, times the angle, 0.228. I'm going to multiply those numbers together, and when I do that, I get 1.14 inches. Let me see. Yeah, I agree with that. Okay. So what about this guy? Well, the problem is I want to find the arc length, but the angle's in degrees, so I just have to convert. You can convert and then use that formula, or you can do it all at once. I'm going to do it all at once. Looks like this. S is equal to the radius, 5 inches, times theta, all right? But it's got to be in radians. So I'm going to take 37 degrees, and then I'm going to convert it, times pi divided by 180, which is how you convert it. And you'll see that these degrees are going to cancel out, and my units are going to be in inches. So if you multiply 5 times 37 times pi and you divide it by 180, you get 3.2 inches. All right, let's do this, the second example, which says find the area of the sector. Find the area of the sector, okay? And it says, with the central angle of the given central angle with a radius of 10.5. The radius is 10.5 feet, okay? And we're going to find the area of the sector. So for part A, they gave us, the first angle that they gave us was theta is 1.74. And the second one that they give us is theta is 105 degrees. Okay. So we sort of have the same situation. The first angle's in radians, so we're ready to use the formula, and the second one is in degrees. We have to convert that before we can use it. So the area of the sector is 1/2 r squared theta. So area is 1/2 r squared, 10.5 feet squared, times the angle, 1.74. And so order of operations says square exponents and then multiplication. So you'll square that, and you'll multiply by that, and you divide it by 2, and you will get 95.9 square feet. And then here, The problem is this is in degrees, so we're going to convert it. So the area of the sector is still 1/2 times the radius, 10.5 feet squared, times the angle, but now I have to convert this, and I'm just going to convert it right here. So that converts it to radians. This, you'll see the degrees cancel out. And so the units are going to be in square feet, and so this ends up being 101 square feet. All right, so now let's do the word problems. The first one is about 2 gears. You have a little picture there. It's got a small gear driving a bigger gear. So, and then it asks us to find some stuff. So let's look at this and figure out how we could do this. Let me make some room on my board right here. All right. Ready? It says 2 gears are adjusted so that the smaller gear drives the larger one, as shown in the figure. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger wheel rotate? So it's a little bit hard to see the radius on here. So I'm gonna draw this little. Here's the smaller gear. And here's the bigger gear, and they have teeth on them, but I'm not drawing the teeth on these guys. But the radius of the smaller gear is 2.5. This one is hard to see, but this radius of the smaller one is 2.5 centimeters. And the radius of the bigger gear is, so this is, I'll make it a capital R to distinguish it. That one is 4.8 centimeters. Okay. All right, so what they said, the smaller gear is going to rotate through 225 degrees. And so what they want to know is how many degrees does the bigger gear rotate. So how we have to figure this out is, if you look at these, what these gears have in common is where they're touching right here, right? Where they're touching right. As this one moves, this one moves, and so they're always touching each other. What that is in common is arc length. They share the same arc length. So this one's moving through 225 degrees, and this one's moving through a certain amount of degrees, but what they have in common is arc length. So let's figure out how much arc length the smaller gear went through with 225 degrees. We know arc length, S, is equal to R theta, but we know theta has to be in radians. So for the small, S small is equal to arc length for the big gear. We know these are going to be equal. Let's figure out the small. It's going to be the radius, 2.5 centimeters times the 225 degrees. 225 degrees, but convert it to radians. This is how much arc length the small gear moved through. We know that is equivalent to the amount of arc length that was touching of the big one. So this is equal to, let's talk about the big one. His arc length is going to be still R theta. The radius of this guy is 4.8 centimeters times theta. We don't know what this, how much angle this one moved through. So we're going to solve this for his angle. How will we solve this equation? We'll divide both sides by 4.8. And that's going to help it. We can say 2.5 times 225 times pi divided by 180 will give us this, and then we'll divide that by 4.8, and we'll get that theta is equal to, when you do that, you will get theta is equal to about 2.18. 2.18. And so that is the amount of degrees, the amount of angle that the big gear went through. But they said, put it in degrees, not radians. So the last little bit we have to do is convert this back to degrees. So we'll say 2.18 times 180 degrees divided by pi, just to do the conversion. And how many degrees did the big gear end up rotating through? It ended up rotating through 125 degrees. So that's how you can do that little word problem. Let's look at the last one, which is not very hard. It has to do with the area of a sector. So this is how it reads. It says, the Ford Model A, built from 1928 to 1931, had a single windshield wiper on the driver's side. The total arm blade was 10 inches long and rotated back and forth through the angle of 95 degrees. Find the area of the region that was cleaned by the 7-inch long wiper blade. So let's draw a little picture, and this has everything to do with area of a sector. So if you can imagine driving in a car, not with 2 windshield wipers, but with just one, and so you have this little, it's going back and forth and it's cleaning this area. So this much, let me do it a different color, the black. Let's see. We've got our windshield wiper going back and forth. All right, so here's our windshield. And so here's the wiper blade. But this much of it is just like the arm of it. And this much of it is actually the blade that's gonna start cleaning our window. So really the area of our window that gets cleaned is this area right here. Okay, this is just the bottom part of our windshield. So how far is it from here to here? It says it says that the blade is 7 inches long. So this is 7 inches long from here to here. Okay. All right. And how far is it from here? The total is 10 inches, right? But just the part that's getting clean is 7 inches. So from here to here is 10 inches. So how much is left right here? This has got to be 3 inches. So the question is, what is this area of the sector? We can find the area of the total sector using this formula right there, right? What would the radius of the total sector be? It'd be 10. But this is the only part that's being cleaned. So what we're going to do to find out how much is being cleaned is, let me draw this again so we can see. Let's find the area of the total sector, all of this, and then we'll subtract off this little area right there, and that will give us this one. So this area is going to be the area with the radius of 10 inches, and then we're going to subtract off this little part right here, the area that has a radius of 3 inches, and that's going to give us the area of our windshield that's being cleaned. So it goes like this. Area is 1/2 r squared theta. We're going to take the area of the 10 inch, so this is going to be 1/2 10 inches squared times theta. But you can either, what was the angle that it said it did? It said the theta was equal to 95 degrees. So you can either take this and convert it into radians and then just put that in there, or you can convert as you go. I'm just going to convert as I go. 95 degrees times pi over 180. And then I'm going to subtract this area with the radius of 3. The area of that little region right there is going to be 1/2 times 3 inches squared times the same angle, 95 degrees times pi divided by 180. And so this is the area of the 10, this is the area of the 3, and when I do this in my calculator and I subtract carefully, the area of this region right here is going to be 75.4 square inches. So that's how much of our windshield's being cleaned.